I think we can slowly start with the introduction.
Yes. With an introduction, let me say good morning, good afternoon, and good evening, to the participant. Thanks for being here with us. Many of you are already participating to other webinars, so just let me say that as GMI, we are conducting several webinars since now a couple of years, and we touch different kind of topic ranging from intrinsic safety, cyber security. Today, this time, and we run also webinar about application of GMI specific product, how we solve a certain application, certain problems. Today, it's time for functional safety. So we have the privilege to have here Tino, our functional safety director at GMI. Many of you knows him. Most probably some of you have been also trained in functional safety. So today we have again a webinar about functional safety. I'm not giving any detail on that because I will leave the speech to Tino. Immediately after, I could give a small introduction of ourselves. Okay, to say that we are here with Tino. Tino has many years experience in our process industry, specifically focusing on functional safety. I have also some years experience in functional safety. Luckily, I had the chance to work together with Tino for many years, and now here at GMI. So some few information about this webinar. You will receive first of all a copy of the presentation that you are going to watch. You will also have the chance, in case you believe you missed some step, you have the chance to watch the same presentation, the same webinar on which is available on our YouTube channel. At the end of the presentation, of the main presentation, we have a Q&A session. We collected while during the registration process some questions from you, and we put together in one presentation. So at the end of this main presentation, we will go through to that. I think we are talking about something like 6 or 7 questions. And finally, you have the chance with the chat box, not chat box, but question and answer box, to raise a question during the webinar. While Tino will talk, I will be monitoring this, and I will stop him in case of any question is coming up during the presentation. So very short, before to leave the speech to Tino, I would like to introduce shortly GMI, in case I am supported by the technology. I should be able to change a page. Yes, I have been able to change page. Okay, so GMI shortly, we do what we do. We do field interface with special focus to safety. And again, functional safety, intrinsic safety, so any equipment that we have, either it is suitable for intrinsic safety application or for functional safety application, or both of them. So you find our equipment in packages, in automation packages like DCS, ESD, BMS, and so on, as well as in main industrial sector like the oil and gas, chemical, petrochemical, food and beverage, pharmaceutical, and so on. We are an Italian company. We produce everything here in Italy. On the other hand, we are available and present worldwide with offices, with the partners. Okay, here just some few numbers which shows, give you an idea about GMI figures. And yeah, the second last number is the 20, which are the number of functional safety training, which we will have now the chance to talk about a little bit later. We as GMI arrange worldwide. Of course, being a manufacturer of safety equipment, the quality is for us one of the most important things for us and for our customer, of course. So we have a highly automated factory here in near Milano, in Monza. We do everything here and we test everything. So we are so confident of our quality that we deliver our product with 5 years warranty. We deliver our equipment worldwide. So being a quality system, a quality company, and delivering worldwide, we have all necessary certification in order to prove the quality, our quality system, as well as we have all certificates which are necessary to use our equipment worldwide. What else? Very, very shortly, because the topic today is not GMI, but it is the functional safety. This is just one page showing the product line of GMI. So we range from intrinsic safety barrier to safety relays. We have isolators, power supply systems, as well as multiplexer and hard multiplexer. We have solution, different kind of solution for installation, including dedicated termination board. And finally, we have solution for surge protectors, loop indicators. And the last bullet is not a product, is showing our expertise in intrinsic safety and functional safety. We provide consultancies, training on these two topics. This is shortly a list of customers that we have, ranging from system integrator up to end users. As promised, I keep it short. I kept it short. I leave the speech to Tino, so giving him the chance to enter and to discuss, develop the topic of today. Okay. Tino, it's you.
Thank you, Mauro, and thank you, GMI, for giving us another opportunity to share some of our know-how with the industry. Today's topic is a simple topic, to my understanding. And as Mauro was saying, we have collected some questions during the pre-registration of this webinar. And I was astonished, I was surprised how many questions we got. And I made a selection. I took like 6, 7, 8, whatever, of the most important questions out of there, which I already prepared an answer. Even see some of the people that asked the questions are actually joined. They are also here in the panelist. So today's topic is minimum architectural constraint according to the standard, the function safety standard, and I will refer both to the IEC61511 and both to the IEC61508, which for both standards are in the edition 2. I start here with a very quick overview of the life cycle of the 61508. And unless you are a manufacturer, I doubt that you as an end user, an operating company or an EPC contractor would ever use this life cycle. This is more for developers of hardware, software, like the ones that are working in GMI when they are developing one of the new interfaces for a hardware point of view, and they want to comply to a, let's say, certain safety integrity level from a leading standard called the IEC61508, well, then certainly they will have to take this life cycle very close to heart. The principle of a life cycle is nothing more than a working principle, step per step, on how to carry out your activities, how to check them, how to document them, and how that someone else, we call that assessments, can make from someone else's work to prove it is done correctly. As Mauro was just showing you a very brief overview of all the certification that the manufacturer GMI has, that's exactly what they have to do, is that once they reach a certain product quality, I mean, once they have finished the development, then they will invite one of the accreditation offices or companies that can help them, independent from GMI, to make an assessment, to make a statement how safe their products are to be used. Hardware fault tolerance was already in the edition 1 of the 61508, and I'm going back to 1998 when the IEC 61508 has been released. And many people will call this HFT. HFT stands for hardware fault tolerance. Very simply explained, how many faults you can tolerate and still carry out your safety function correctly. If I want to explain this simple, you take an aircraft, you take a twin engine aircraft and assume that you need one engine to land safely. Well, if one engine would fail, we would call this a hardware fault tolerance of 1. We can still carry out our landing safely with one engine. If you have a mono-engine aircraft, there is no hardware fault tolerance. As there's only one engine, that means there you cannot tolerate any failure. That's the same principle we do with our safety instrumentation. When we speak about the hardware fault tolerance, we ask ourselves the question, how many of those instruments can fail and we can still achieve our safe position? And that's basically what the topic will be for today, because we have different conditions in both standards on when do we have to apply a certain hardware fault tolerance number according to a specific condition, which will be hopefully clearly explained here later on in this webinar. Since the year 2010, we have the edition 2 out of the 61508, and there we came with a new concept in the standard called Road 1H and Road 2H. And Road 1H, that's basically what we carried over from the edition 1 from the 61508, meaning that if you are a developer of a new product that doesn't exist on the market, you cannot say, well, we have used this before, therefore it is probably safe to use. You cannot do that. So if you have to start from scratch, we will do, I call this a theoretical approach, where they will make an assessment to make a judgment how safe that equipment is to be used. That's still called the Road 1H. That's also the famous safe failure fraction, as some of you may have recognized on some of your documentation on your safety equipment. The Road 2H that was introduced in the year 2010 was called proven in use. That means the manufacturer needs to collect from an install base by the customers, needs to collect some failure data, and needs to prove following certain, let's say, quality standards on how to collect that data in terms of confidence factors, in terms of quantity, etc. You need to prove how safe it is to use that type of equipment. So Road 1H, that is more the theory, which leading into safe failure fraction and into some report, whereas Road 2H, it is more collecting data. And nowadays, we see more and more, let's say, manufacturers or vendors who are mixing both Road 1H together with Road 2H for a very specific reason. This brings me into the 2010, which I already mentioned. I even quote here 7.4.4. That means if you go to part 2, which is a normative hardware section of the standard, and you would go to chapter 7, item 4.4, there you will see how they explain the hardware safety integrity architectural constraint. That means if you follow the Road 1H, there they will base that on the safe failure fraction, and they will follow the concept which we call type A, table 2, or type B, table 3. I have later on in this webinar a picture for you. Road 2H, as already was mentioning, that is the proven in use. It is based on component reliability data collected from an install base that will be based on that data. You can follow a different table, which is not the table 2 and 3 from the 61508. You will follow, in that case, most likely the table 6 from the 61511, which again, I got a picture in this webinar later on. When we go with the first option, which was Road 1H, that was the theoretical approach. As I said, people, let's say accreditation officers or specialist experts will make an assessment and they will come to a judgment. If you look on the left column here, and I'm trying to hover here with my cursor, if you see here the left column, that's called the safe failure fraction. The safe failure fraction will represent a certain quantity of how many hidden danger undetectable failures are hidden away in your equipment, and it will be a ratio from the overall failure rates in that equipment. That means based on the percentage ratio, the higher the percentage ratio, the less dangerous undetected failures are hidden away in your equipment, the higher SIL you are allowed to use it for. If you are here at type A versus a type B, simply speaking, anything with a software firmware chip on the, let's say, printed circuit board or inside your instrument will always remain a type B. So all your smart and hard transmitters, all your safety PLCs programmable with software are always type B. If you take a classical solenoid, you take a classical relay, where there is no software in there, in that relay. I was thinking on the sophisticated relay from GMI was doing the line monitoring, but it's not that relay. It's the other relay which only have, let's say, analog components on it. Well, then we will classically will only have a type A. And you can see they make it different. The difference is here in this first line. You see here a 0, a 1, and a 2. That means the HFT hardware fault tolerance, you are allowed, if your safe failure fraction would be above 99% or more, you are allowed to take one single instrument for type A and carry out a SIL3 application with that. Whereas if you go in type B and we go between 90 to 99, which are some or most of your smart and hard transmitters, will sit between 90 to 99. That means that with one single smart transmitter, you most likely will be able to cover a SIL2 application. That's how we used that table. I'm jumping now in the second standard called the IEC61511, which is meant to be used by the end user operating companies for the process industry. And the process industry had a new edition 2 out of the 61511 in 2016/2017. If some people would join in, and I recognize some people from the USA, well, for you, it is since 2018, you have the ISA 61511, so you took a little bit more years before you adopted the edition 2, which was issued here by the IEC committee back in Switzerland. Anyhow, the life cycle, same principle, same idea, with bringing a working principle step per step into a certain shape like we show here in the life cycle. We hope that people will make less human failures and will be able to increase the work quality. That's the whole concept of the life cycle. We do have other webinars for life cycle, so I don't want to talk too much here about the life cycle. Let me jump into the HFT, or the hardware fault tolerance, based on the 61511. Well, if you look on the definition of hardware safety integrity article constraint, which is here again in the normative section number 1 of the edition 2 of the 61511, and you go to chapter 11, which is your, I call that the hardware engineering chapter. If you go to item 4.3, there you will see the statement that the SIS shall have a minimum HFT with respect to each SIF it will implement. So when the SIS can be split into different little subsystems, like sensors, you may have multiple sensors, you may have multiple input cards, but you may potentially use only one or maybe a redundant CPU card in your safety PLC. You may go over to a redundant digital output module into a dual safety relay. From a dual safety relay, you may go maybe to one single solenoid. It all depends on how this architecture is being built up to comply to the level of SIL that you want to achieve. Now, the biggest change in 2016-17, when edition 2 came out of the 61511, they are preferring that our end users or operating companies will use their own data, their own failure data from their own equipment, with their own experience, with their own routine of proof testing, etc. That is the whole purpose of the edition 2 of the standard. So in other words, the focus should be on collecting quality feedback failure data from installed-based equipment on site. And if you can prove you have done that, then you are allowed to follow the preference of the 61511, which we call prior use. And I have put here between brackets with an asterisk or with a star on it, I call this method number 3, because in my lectures, in my training that I've been doing for many years now, I'm using 3 different methods, method 1, 2, and 3. And method number 3 is the latest one we just explained here, is the preference from the 61511, which will refer to that table 6, which is in contrast to the road 18 from the 61508, which I will call again in my personal notes. I call this method number 1, but I do have a picture coming up on that. So there are 3 potential solutions for all the end users, engineering contractors, operating companies listening into this webinar. If you need to comply to the IEC or the ISA 61511, second edition, well, then there are 3 potential solutions, and most likely you will have to mix them. I try to give you a simple example. Assume that you buy a safety relay from GMI. That safety relay from GMI will be according to the 61508 Road 1H, will have a safe failure fraction, will have all the necessary data and the safety manual provided to you. So there you can clearly select method number 1 using the Road 1H, the constraint table from table 2 or table 3 from the 61508. Now, if you're an end user and you want to use maybe one of your solenoids you have been using for many years, you have some good data, etc., it's all nicely documented, well, then there's a potential chance that you are allowed to use method number 3, which is called your prior use. Now, if you don't have prior use, don't have method number 3, you don't have method number 1, that means you didn't buy a Road 1H equipment, potentially you may have some vendors that will sell you a Road 2H based on proven and use, which is the middle one, which is method number 2. And I tried to combine that, and I first explained the table before I show you the summary picture, because in that summary picture, there will be a giving summary for you in which option you can now select. Table number 6, again, is the preference of the 61511 edition 2, which the whole idea is called Road 2H in the background. Road 2H, either from the 61511 prior use or proven in use from the 61508. So providing you have quality feedback data and you can prove that, then you are allowed to build any SIL2 loop with an HFT for low demand mode. What is low demand mode? That is when your equipment under control or when your safety function is no more demanded, no more than once per year. If it is more than once per year, we call this a high demand. So you can see we distinguish between SIL2 low demand, SIL2 high demand. For a SIL2 high demand, the standard 61511 requires today to install a minimum redundant solution while you have to have an HFT of 1. An HFT of 1 can be, as an example, can be achieved, but I think I got a table coming up in my slides, but very briefly, HFT of 1 can be achieved with a 1 out of 2 or with a 2 out of 3. Whereas an HFT of 0 can be achieved with a 1 out of 1 or with a 2 out of 2. I got a poll question coming up, Maru, to see of how many of our participants are really following. And I will read the poll questions for you aloud. So there's only one answer possible, and only one is the most correct and the most complete. So the question is about this topic that we handled today called the architectural constraint as per the IEC 61511 or the ISA 61511. Answer A. That 61511 can use either method 1 or 2 or 3, but only one method per safety function is allowed. Option number B, or answer B, is you can use method number 2 and method number 3, both based on Road 2H mixed per SIF or per SIF. Answer C, can use only Road 1H when claiming prior use for the IEC 61511. And the last answer is D, can mix per SIF, so per safety instrumented function, you can mix method 1, 2, and 3 all together per SIF, all as applicable. Which one do you believe would be the best answer? Or the correct answer, not the best, the correct one. Okay, Mauro, they're still coming in.
Yes, there is a good response. We wait again some few clicks. So few seconds again. Don't be shy.
Okay, I think we are nearly there.
I think we can stop it.
Okay.
And I can share it. Can you see the shared results?
I think I do, yes. Sorry, I was looking at another screen here already. I got a second screen open. Architectural constraint as per. So let me see. 44% took answer A. Can use either method 1 or 2 or 3, but only one method per safety estimate function. Well, I have to disappoint you because that is wishful thinking. In my entire career and experience, it's very hard and rare that our entire, let's say, safety loops will use only method 1 or 2 or 3, but only one method for the entire solution, because that's basically not even achievable. So it's certainly not A. That's also not what the standard is expecting from us. Answer B, can use method 2 and 3 based on road to H mix per SIF. Well, that's the preference from a standard. However, they don't say you can only use method 2 and 3 if you call prior use or proven in use. The correct answer was here, and I see we have about 38% on answer number D, can mix per SIF method 1, 2, and 3 all as applicable. And that's basically what people are doing. All the safety PLCs, the majority of the safety PLCs, let's say from all of them that I know, only one of them is based on proven in use. All the other ones are all based on Road 1H. So the majority, let's say, of the safety PLC leading vendors are all Road 1H. The majority of all the equipment or interfaces that GMI is selling is also based on Road 1H. So you see that you will start to select. You may buy a smart transmitter. Your smart transmitter may be based on Road 2H, based potentially on proven in use from the manufacturer. Then you may go over a sill barrier from GMI, and a barrier will be on Road 1H. Then you go into a safety PLC, again you are on Road 1H. Then you jump on the safety relay, again you are on Road 1H. But then comes the solenoid. On the solenoid you have nothing, zills, not even a paper. So how do you do it then? That means that we will have to check that particular solenoid in your application. Do you have some records from that? Do you have some test records? Do you have some failure rate? And potentially we are trying to build up a case here where we will use that solenoid as a Road 2H, but as prior use from an end user. And then you come to the final element, and then it's a bit of nothing and a bit of everything. In other words, your smart positioner may have a paper. Your actuator may or may not have a paper. If I would take as an example a ball valve, and you have a ball valve from manufacturer X, that may have nothing. So how do you determine then the SIL level of that final element, which is a combination of 3 different vendors? And that's the struggle that you will have. So, summary, I will close this, Maru. Let me continue. Summary on this HFT, just for those who are not so fit, I'm trying to make it, let's say, simple in the explanation table over here. If you first look on the middle table, that is when you care about safety. In other words, when you need to build a hardware fault tolerance, and we're purely focusing on safety availability. So question is, can I achieve my safety function, yes or no? Well, then a 0 can be built with a 1 of 1. A HFT of 1, as I mentioned previously, can be built with a 1 out of 2. Or an HFT of 2 can be built with a 1 out of 3. That means you will have to, if you have, let's say, 3 fail to close valves on one pipeline, you can close either one of them. That means even if 2 are not working, you can still close. That's called an HFT of 2. Of course, production people, and if you do have some production people listening into this webinar, they say, oh, we don't like that. Because when you have 3 valves and there's 1 valve closing for no reason, we're losing production. And yes, you are right. That means if you look on the production availability, and we want still to achieve an HFT of 1, and I take the middle one over here, you want to achieve an HFT of 1. That is why most of your hard and smart transmitter sensors will be built as a 2 out of 3. That means only when 2 transmitters recognize the same value, you will trip your production. Whereas if you only had a 1 out of 2 transmitter setup, if one transmitter would believe it has a high pressure as an example, it may trip your production. So production people do not like this type of architecture because it has a potential spurious trip. So if you want to tolerate 1 spurious trip, that's where you will go here in a 2 out of 2. but you have not achieved any safety with a 2 out of 2. That's only good for production availability. When you go for a 2 out of 3, it's a bit of both. You have some safety availability with that because you can tolerate one dangerous fault in your architecture, and you can tolerate one spurious trip. And if you want to have everything, let's say two HFT for danger failure and one spurious trip, that is where you will opt for obtain for a 2 out of 4. And that's the example which I'm just giving you. A 1 out of 2 is great for safety people. It's the worst nightmare for production people because they don't like that. Simply speaking, one valve can trip their entire reactor inlet. If you go for a drain function on a reactor and you see 2 fail to open valves, well, clearly that is the best solution for production availability. If one valve starts to leak or starts to go open, you're not losing your production yet, but that's also the worst solution for safety. So somehow we will have to think about that, how we can combine both safety availability and production availability. Right, we are coming to the end of a summary before we go into the Q&As. This table over here is mentioning this method 1, 2, 3, which I actually mentioned before here in the webinar. That means if you look here on the right-hand branch, we start here on the right corner. I call this method number 3. That is the main preference of the IEC IEC61511, which is totally depending. Do you have or not have quality feedback data from your own equipment, in your own installation, your own environment, your own procedure of maintenance, your own proof test intervals, your own proof test coverage, etc., etc. So there are many questions before we will decide, yes, we do have quality feedback data. We call that prior use. And you will have to have a confidence factor. The confidence factor will be called 70% confidence factor. You need to prove on your prior use data. The standard recommends you to collect your data either by the technical report number 4. And that should read here, there's a new one out. I see that this slide has been taken from a different lecture from me, because in the meantime, this is by memory 2020. Is a newer report 4 out of the ISA. TR stands for technical report. But if you look for report 4, the old one is obsolete, so there's only the new one is available. Alternatively, you can follow and use the guidance from the NAMUR, the NE130, that is how to collect your failure data on your SIFs on your installation. Your FVL stands for the full variable language or limited variable language, needs to have a diagnostic coverage inside for more than 60%. I call this typically a giveaway because with no doubt, if it has a microchip in there, it has been programmed, your diagnostic coverage will be more than 60% on all the instruments that I've seen in the market. So the second bullet, I would not worry too much. I would more worry about how good is your quality data that you have collected from your own, let's say, instrument. And the last one is they also require to prove performance evidence similar operating environments. Give you an example. Let's say a multinational company may have an installation somewhere in the south of Houston, and maybe the other installation is somewhere in the middle of Germany. Well, clearly the environment may be different. The end user name is maybe the same. The environment is certainly different. That means the influence on the equipment may also be different. That is why we are looking for performance evidence similar operating environments. Now, if you don't have prior use, maybe you can go to the middle one. And maybe your manufacturer may help you by proving that they have collected some failure data. The question is, do you send back your failing instrument to the end user that the end user can learn from their failures? Or do you say, well, you know, my courier shipping cost is too much, I throw it away, I buy a new one. That means the manufacturer sells more, return is minimum. That means it may not reflect the reality. Also something that you should think about. Anyhow, method number 2, we call this road to H, which is here in the part number 2, which is the normative section for the hardware section of the 61508. And there we have the proven in use. The manufacturers needs to prove feedback from similar application/environment. The question is, does the manufacturer realize or really knows or can prove where all his or her equipment has been installed? That's the question. Second, the manufacturer needs to prove that the data has been collected as per leading international standards, and they refer here to two standards. One is the IEC, the other one is an ISO standard. And then there needs to be done an evaluation. On many other certificates that you may see circulating in the industry today, you may see that they claim Road to H, and there the expert judgment, that means the company who has made the assessment has made a judgment to prove that that equipment can be used in a certain seal integrity level. So both are called Road to H, both are based on quality data, and there you can use that table which we call table 6 from the IEC IEC61511. If you have none of that, you have no prior use, you have no proven use. There is only one method left. It's the left one over here. That is Road 1H. As an example, I am following a new development from a new product, which has not been launched on the market yet. Well, those people cannot claim proven or prior use because it doesn't exist yet. And they also have to start. That means they start like they have done in 1997, 1998 with edition 1 of the 61508. They will have an expert make an evaluation and will declare a certain safe failure fraction. That safe failure fraction will be done by a method called failure mode and effect analysis. That's here failure mode and effect diagnostic analysis. That's an FMEDA. They also have to define what is a systematic capability. You may have learned already since 2010, besides the SIL number, your systematic capability is even more important than the SIL number. There they also have to declare if it was a type A or a type B. And all of that needs to be found for you normative, that means mandatory required. You need to you need to receive a safety manual per compliant device on the 61508 as of April 2010. So we are now already 2022, so it's 12 years that all the vendors claiming 61508 shall give you as an end user or an engineer shall give you a safety manual to understand how to install it, how to look at your hardware fault tolerance, etc., etc. Some of the manufacturers will also give you a kind of a certificate as an evidence, which is not a requirement from a standard. It is more the manufacturers between each other as a competition. And of course, you also have to know what is the likelihood of a failure in function of time. So they will have to give you a PFD or a PFH. Now, method number 1 doesn't follow that table. And you will see that for method number 1 over here, it's a lot more restrictive in terms of hardware fault tolerance because they fully claim or they fully look at as a reference to the safe failure fraction. And the safe failure fraction here in table number 6 of method 2 and 3 is no longer being required. And there is a reason for that. I will not give you the detail now because it's just covered in the Q&A, because I had an interesting question from an engineering manager who was posting that question. And I thought I want to share that with the public. So that is why I will do that during my Q&A. Because the question was, why is there such a difference between the 61508 safe failure fraction and the 61511 with no safe failure fraction? Why do the standards are not agreeing with each other? And of course, there's a very specific reason for that. So summary, left-hand side, method 1, that's a theory approach. Right-hand side, that's the field quality feedback. Feedback can come either from the end users providing it to the manufacturers, and the manufacturer can make the collection of that. That's Road to H called proven use, or the the end users individually can call it prior use by collecting their own data. Question will be, of course, that's the biggest challenge we see since 2010. Who has quality, fair feedback data that you can actually understand, that you can actually believe, because some of them are almost too nice to be written down on paper. So, a poll question, Mauro, that's safety availability versus production availability. And I like to play a bit with configurations here or hardware architectures, which is applicable for everything. can be applicable for a solenoid, for a valve, for a PLC, for a sensor, a barrier, for everything. So a 1 out of 2 and a 2 out of 3 are the same for production availability, is answer A. And again, only one answer is the most complete and the most correct. A 1 out of 2 is better for safety availability than a 2 out of 3. That's answer B. Answer C, a 2 out of 3 provide both safety and production availability. Answer D, a 2 out of 2 and a 2 out of 3 provide the same safety and production availability. And last but not least, answer E, 2 out of 2, 2 out of 3, 2 out of 4, all architectures provide the maximum safety and production availability. Which one in these tricky answers do you believe is the only one that is correct? Because all the other ones I can, well, when I read them, it's actually quite simple, but there's only one correct in the entire answer.
Okay, few clicks more and then we stop it.
Okay, Mauro.
Okay, 3, 2, 1. I think I stop it and I share it now because also we got good response. Let me share it now.
Okay, well,
and you can comment.
The good news is that the majority was correct. Majority took answer C, that a 2 out of 3 provide both safety and production availability. And let me start with why the second group of 40% answers is not correct. 1 out of 2 is better for safety availability than a 2 out of 3, and that's certainly not true, because a 1 out of 2 and a 2 out of 3 both have the limitation of an HFT hardware fault tolerance equal to 1. So both can only tolerate one danger failure in a 1 out of 2 and a 2 out of 3. So a 1 out of 2 is certainly not better for safety availability than a 2 out of 3. And the other answer, that was 15%, so that's minority. Some people believe here that 2 out of 2, 2 out of 3, 2 out of 4, all architectures provide the maximum safety and the maximum production availability. Well, the problem is there. A 2 out of 3, 2 out of 4 is correct, both maximum safety and maximum production availability. The problem lays in here with a 2 out of 2, because a 2 out of 2 has no, and I repeat, has no safety availability. When you have 2 valves, but you need both valves to open before you can achieve your safety function, well then, you cannot tolerate that one valve not going open. So 2 out of 2 is mainly meant to be used for production availability, has nothing to do with safety availability. All right, Mauro, I think we are nearly there, because yeah, let me just summarize very briefly, but we'll jump into the Q&As, question and answers, at least the answers that I have been forming based on your questions that you were giving us in your registration. So what Mauro was saying, that the last box of all the products was talking about training. Besides training, we also do some service. So we provide here the whole branch of IEC61511 lifecycle support services. Goes from PHRAs like HAZOPs, we do some LOPAs, we do some SIL determination, verification. We actually, currently we are working on a safety requirements specification for a client, and myself, I've been involved several times in functional safety management and also in some assessments on site with end users. I'm happy to say that we are getting more and more attraction, or more and more, let's say, interest in delivering service also on the 62443, on the IT/OT security, which is the cyber security for industrial installation, because there's now also a requirement from the IEC ISA61511, you shall carry out a security risk assessment. Only therefore, we have training, and we have training to help the customers to be more aware. So myself and some of my colleagues are still providing the functional safety engineer SIS training under the umbrella from TUV Ireland. For those of you who are living somewhere in the area of Europe, we will hold a symposium with TUV Ireland next week, where I will also have a short lecture on a very similar topic of what we have done now, but I will focus more on the determination of mean time to restoration versus the mean time to repair. So besides that, we also are actually carrying out cybersecurity training. So we have 2 trainings. One is called the fundamental course, which is the one that will be carried out next week in France for a customer. And then the week after, we are doing the same training in combination with security risk assessment training. So that will be in Romania for an end user. So both of those trainings are all being delivered by a group of people that I'm working with together, because I cannot do all myself. So I got some additional help. And then we also do in-house training seminars. And of course, we do have some webinars still to follow. Plus, last but not least, we have also that book here called the edition 4th, or it's the 4th edition print, which is the safety instrumented system, where there I had chapter 7 and 8. Chapter 7 is an executive summary of the 61511 edition 2 changes. And in chapter 8, I have been writing the safety requirements specification. I actually have a question coming in, Mauro, that I will quickly read before I will stop sharing that. Okay. Appreciate to have another session focusing on GMI, STA, architecture, and function. Ooh, STA, Mauro. Does it ring a bell for you? STA.
This is, yes, the trip amplifier.
Ah, okay. All right.
So,
okay. So that's nothing for me then. Good.
Yeah, it is for me. You can just drop me an email, okay, on an email that you can see on the presentation, and we can follow up. Certainly, we can follow up, no problem.
I'm just trying to share my Q&A. Should I open the Q&A, Mauro, or will you open it?
It's up to you. I can open it. I can share it because I have already opened it and I need just to share it.
Okay, you can share it.
Can you see that?
I can see it.
Okay.
Okay, let me just make it a bit bigger so I can also read it. Okay, I'm with you. Okay. I just propose that you click.
Yes.
Okay, I will read the question also, because then I will probably remind what was.
Yes, please do that.
Hardware fault tolerance for a safety instrumented function loop will be decided based on IEC61511 or IEC61508, question mark, which is more stringent? Okay, right, so, well, I think the answer was probably already clear during the webinar, or I hope it was clear with the summary picture with method 1, 2, and 3, because basically that is what is bottom down, that you can choose depending on what type of, let's say, data do you have on your equipment. Do you have some theory approach where you have the road 1H with equipment, with safety manual, with data, then you can actually follow that 61508. And yes, the 61508 is looking at this famous or infamous safe failure fraction. And I will come back on that safe failure fraction also later, because I made a slide for that. If you don't have the 61508, let's say, data on that type of equipment, maybe you go to prior use. Well, that's the method number 3. And the prior use is certainly for the operating company / for the end users. Again, it all depends on the subsystem or the interface that you're going to try to use or not. Because if you have a newly developed equipment, there is no potential way that you already have some quality feedback data from some installed base, because it hasn't been released yet. So therefore, you are limited to this, let's say, method number 1, safe failure fraction, let's say, declaration of that equipment, and able to select the architecture correctly by 61508. Versus, if you have some more data in the future, well, then you can go over to the road 2H. And you have seen that it's clear that the road 2H is less, let's say, restrictive than the road 1H. Yes, Mauro?
Be sure I'm trying to, okay.
Is any suggested architecture available in the IEC standard for PLC/ESD merges down system applications requiring SIL applications? Okay, Mauro? Oh, okay. Well, sometimes I make my answer also on my lab also easy at all. Let's just show again the picture, which is a summary. Where is your safety PLC sitting? That is the first question, of course. The IEC standard 61508 and 61511 is not, and I repeat, is not written for a manufacturer specifically for safety PLCs. The 61508 is written for anything with electrical, electronic components or programmable electronic safety related system. So if a safety PLC follows under EEPES and they want to claim how safety integrity level they have, well then they will have to follow the 61508 edition 2. And then most likely the safety PLC vendors, as I said, majority are all following road 1H, not road 2H. There's only one vendor based on collected of years of data on a specific branch in the industry, which was not processed, but they also claimed that that safety PLC, which was used for machinery application, can also be used for process indication. Well, that is where they claim the proven in use on a SIL2 safety PLC. Yes, Maro.
I don't know why. Okay, here it is.
Could you please specify what the new requirements towards the vendors, engineering, contractors, and the end users? From an operational point of view, no new measures have been taken in my company at least. Just looking at my list, I see you are still online. So this is your question that I'm answering, because I recognized your name. I thought, like, let me try to formulate an answer. Mauro, can you just click, please? Okay. So as the other people that did not ask the question or don't recognize the question, the nature of the question is clearly coming from an operating company, that wants to know that since the standard is out, this engineer has not maybe seen direct an impact on some of their, let's say, ways they engineer or they have the architecture going for their safety loops. That's why if you look here on bullet number 2, the focus when the 61511 came out, edition 2, is clearly focusing towards the end user / operating company, saying that it is time to collect your data, not having someone else on the other side of the world collecting data, putting on a table, and you're going to start to use it blindly, believing it's going to be similar to yours. That's not how it should work. So the 61511 is all about quality, feedback, failure data. I cannot underline it enough, because some people still, when we see they do projects, they buy somewhere a commercial database, they whack in the data into a software package, they push the button, there comes a report, and everyone is a happy family. That's not the way we should fool each other on paper. We should focus on data which is relevant to your application, your environment, etc. And that's something that I want to underline again here with the second bullet. It's all about the confidence factor of the data that needs to be proven based on your records. So short answer to this engineer, well, all your vendors or EPCs or the engineering contractors, depending on what your requirements from your end user company are or operating company are, will potentially need to follow one of the methods, 1, 2, or 3, which was previously explained on the previous slide, but also in the webinar. So basically, my final question to the engineer would be, what does the management of this operating company wants to comply to? Do they claim they comply to the 61511 leading standard? If yes, let them prove which method they follow. Let them prove or ask the vendors to prove which method they follow. Okay, so I cannot answer this. That's something that needs to be answered inside, let's say, the management of the company. What, let's say, way forward will they go with their installation? Yes, Mauro.
Here where is, okay, next.
How to determine architectural constraint if the supplier reports only MTBF products? Okay, Mauro? Well, simple answer, not possible. Absolutely not possible. Because MTBF stands for the mean time between failures. That's a certain frequency, a certain time between two failures. What does a frequency of failures have to do with a hardware fault tolerance? You could say, well, it represents a certain quality representation of my equipment that it will fail in a certain time. I would say maybe yes. But that's not what the hardware fault tolerance is all about. The hardware fault tolerance is a quantity of number of dangerous failures that your equipment can tolerate and still achieve safety, regardless if that equipment fails every hour, every day, every 100 years, every million years. So MTBF has nothing to do with HFT. Question would be to you as an engineer, the supplier supplying you with the MTBF products only, do they claim a SIL level? If they say yes, well then, since 2010, for the last 12 years, that vendor will have to provide you with a safety manual. If no, well, my simple answer is search for a different supplier that will follow the 61508. It will make your life a lot more easier. Okay, Mauro? All right, that was also a very long question. Is it mandatory to follow IEC 61511 and 61508? Mandatory? Or is it a recognized and generally accepted good engineering practice, which is there then abbreviated, to follow the 61511 and the 61508? Okay, Mauro? Well, both 61511 and 61511, oh, I made a typo, I made a mistake. So this, sorry for that, I really apologize. You see, I read it twice, but the first bullet should read both IEC 61508 and 61511, so not twice 61511, of course, are both recognized as generally accepted good engineering practices. My question to this engineer would be, if you claim that you follow your generally accepted good engineering practices, are those practices being written both on the 6, or do they refer to the leading standards of the 61508 and the 61511? If yes, there's no problem to follow that good practice. If no, I would recommend to review your good engineering practices, your guidelines that you have in your company, and make sure that the guidance are following the leading guidance in the market, which again are the 61511 and the 61508, but make sure that you actually refer to the edition 2 of the standard, because there's quite a difference between the previous old edition ones and the edition 2s. Yes, Mauro?
Yes, here there is another question.
What is the actual role of safe failure fraction when defining architectural constraint and determination of the HFT parameter? Well, that was a very clever question. The role of the safe failure fraction is only applicable, of course, if you go only to road 1H, which was method number 1 in this webinar, which was table A and table B, or type A and type B, which was table 2 and 3 from the 61508. Safe failure fraction is not to be used for road to H prior use or proven in use, which was table number 6. And again, this question with safe failure fraction is coming back now on the last question, Mauro, and then I will go more in depth on safe failure fraction. Yes, and that was the question I really liked, because that is spot on. That's someone that understands a little bit of the secrets behind those committees on the standards. To achieve a certain SIL, the IEC 61508 put emphasis on the safe failure fraction, on the SFF, which was this ratio, while the 61511 does not. And the question was, why do IEC 61508 and IEC 61511 take a different view on this? Yes, Mauro? Well, I'm starting to say, to be, let's say, neutral, political correct, there has been a lot of water under the bridge. In other words, there have been a lot of background discussions on this previously, before the edition 2 of the 61511 has been released. Basically, the committees, and you have to see there are, let's say, 26, 27 different nations around the world, which are gathering into meetings and are trying to debate and to agree with each other on what is the way forward on a good engineering practice. Well, there were certain countries which were totally and absolutely, utterly against the use of safe failure fraction, for a very simple reason that some manufacturers, between brackets, some clever creative engineers, made an abuse of the quantification on how they achieve a safe failure fraction ratio. And believe me, I'm not a mathematical specialist. Otherwise, I would not be able to explain it so simple as I'm trying to do. But if you look on this formula of safe failure fraction over here, you see here all kinds of symbols. The first symbol stands for lambda. Lambda is nothing more than a failure rate. And on the bottom one, you see the total failures inside your equipment. And it's all about the little one over here, or little one, the last one over here, which is called the dangerous undetected failures. Those are the failures that will stop you from achieving your safety function. Those are also the failures that no one else can find besides you. You during your proof test with the necessary, let's say, the efficient proof test coverage. So the lambda DU, or the danger undetected failures, that is actually what it's all about. If this ratio goes down of danger undetected failures in numbers, you can see that here the lambda S plays a very important role. In other words, if I'm putting a lot of safe failures in my formula, the danger undetected failure becomes irrelevant. And that's why there were some vendors who were achieving safe failure fractions sky high on their definitions on how safe their equipment really was. That means that the committee of the IEC61511 was led by some, let's say, groups of countries who were saying that, you know what, we do not agree on how they determine the safe failure fraction based on the IEC61508. Therefore, we will agree only on collecting our own data. And we prefer to collect our own data because that is something that we can trust. And that's the whole reason why the committees of the IEC61508 and the committees of the IEC61511, or at least a standard, have a complete different view on that. So the IEC61511, it's all about quality data collecting, whereas the IEC61508 is two parts. One part is Road 1H, because we have to start from somewhere as a new development. But once we have more and more, let's say, experience and feedback of data, that's where Road 2H is coming as proven use. And that's the entire story, as clear, as simple, as explained as possible. In the meantime, Mauro, there's a new question.
Yes, in fact, I wanted to alert you on
it's
that.
Okay. Our company intends to use non-SIL transmitters for SIF, question mark. Is it allowed as per Road 2H, as per IEC61511, prior use or not? Well, if your non-SIL transmitters have been used by your company and you have good failure data that you can prove, and you can have a certain case that you build up and you can actually prove that as an evidence to the inspector/assessor, there's no reason why you would not be able to use those transmitters. Bottom line is, or let's say the main problem we see is that majority of end user operating companies have not the time, have not the know-how, have not the manpower to do all this root cause analysis on failures on their equipment, and have no good data other than we have, let's say, 1,300 transmitters, and from this 1,300 transmitters, only 2 failed last year. What will you do with that? With only 2 failures in the last 1 year or whatever. That means there is a lot more needed than just a number of failures in your installed base. So there's a lot more to think about. If you are more interested, my recommendation would be read the report 4 of the technical report 4 of the 84 committee, and also read the NAMUR NE 130. All right, Mauro, I was trying to keep it in time.
Yes, thank you for that. Okay, now the very last question for you. We would like to have your feedback about how we did, and yeah, hopefully you found it very interesting. Again, you will receive this presentation. You will see also my email address, and in case of any specific comment or request, yeah, just drop me an email. So yeah. Thank you very much. Yeah, please.
I just want to mention this webinar has been recorded, as well as all the other webinars. This YouTube channel from GMI, where you can actually look at all the previous webinars, including this one. It will be online in the next couple of days. Plus also the slides which have been presented will also be sent to you. I will actually correct my typo, so I'll resend this model to you, because we don't want to send out a typo in our presentation. and apologize for this one single mistake that I now recognized. Okay,
So,
Mark.
again, thank you very much to all for your participation, for your feedback, and see you next webinar, I would say. I will have actually the next one on Wednesday. It will be on intrinsic safety. So you just check on our website which are the subject of the next, and if you find anything interesting for you for your job, you just register it.
All right.
Thanks
Very
a
good.
lot to all.
Thank you. Thank you, Mauro.
Bye bye. Thank you.